heat capacity and specific heat capacity. When we are talking about heat capacity, we are talking about the quantity of heat required to raise the temperature of a body or of a material by 1 degree Celsius or by 1 Kelvin. In other words, the amount of heat you will supply to a particular material or a substance for its temperature to increase by 1 Kelvin is known as the heat capacity. Let's take, for instance, you have a body, or let's say a liquid, and then you heat it. When you heat this liquid and you place a thermometer inside of it, and when you start heating this liquid inside this container, the moment you observe the temperature has increased by 1 degree Celsius, that heat that you supply is referred to as the heat equals to the mass of the substance, which is the liquid, times the specific heat capacity of the liquid, which is represented as C, and times the change in temperature, which is what? 1. Now, what we are doing here is that there is a particular amount or a certain amount of heat that is supplied to a substance that will cause that substance to increase in its body temperature by 1 Kelvin. In that case, that heat supply is what we call heat capacity. Now, let's talk about this aspect that has to do with the C, known as the word specific heat capacity. A very important part. Specific heat capacity is telling us the quantity of heat that is needed to raise the temperature of a unit mass, I repeat, of a unit mass of a substance by 1 Kelvin or by 1 degree Celsius. Let's take, for instance, I measured a quantity of water, a very large amount of water, and then I started heating it to the point that the temperature of the water increased by 1 Kelvin. In that case, the quantity of water I measured was not 1 mole of water, was not a unit mass of water, it was a known mass of water, large amount of water. And when I finished heating it, the temperature increased by 1 Kelvin. In that case, because the water is not just a unit mass of water, I am talking about the heat capacity. But now let's talk about a unit mass of water. Let's remember that water is represented as H2O. And then the mass of 1 mole of water, because this is 1 mole of water, is going to be 2 times 1, because hydrogen is 1, plus oxygen is 16. Now I'm going to have a total of what? I'm going to have a total of 2 plus what? 16, which is equal to what? 18 grams. What is this 18 grams telling us about water? It means 1 mole of water weighs 18 grams. I repeat, 1 mole of water weighs 18 grams. Now, if I want to measure a unit mass of water, it means I will get my container. This is my container. And I will add water inside. And I must make sure that this water must weigh 18 grams. As long as this water weighs 18 grams, it means the mass of water inside there is 1 mole, and that is 18 grams. Now, a unit mass of water weighs 18 grams. Now, when we are dealing with specific heat capacity, it means the quantity of heat required to raise a unit mass of a substance by 1 Kelvin. Now, I want to measure a unit mass of water. Remember, a unit mass of water weighs how many grams? 18 grams. So I'll put my water inside this container and I must weigh it. The weight of this water must be what? 18 grams. If it is 18 grams, it means it's a unit mass of water. Now, once I start heating it, the heat I will supply will cause this water to reach a temperature of 1 Kelvin. Now, that heat you supply that will make a unit mass of water to increase by 1 Kelvin, it means it is the word specific heat capacity. So every substance you are dealing with have their own specific heat capacity. If you measure 1 gram if you measure a unit mass of kerosene and you heat it, you realize that the heat you supply that raised the quantity of that raised the unit mass of water by 1 Kelvin will not be the same heat that you will supply to kerosene that will raise it by 1 Kelvin. Here is ethanol, C2H5OH. Ethanol is liquid. Here is my water, H2O. Now, I want to measure a unit mass of ethanol. So let's know how many mass I will measure in my ethanol before I start heating it. Carbon is what? Carbon is 12. Hydrogen is 1. Oxygen is 16. But now let's count. How many hydrogen do I have? How many carbon do I have? We have 2. Which is now going to be what? 24. How many hydrogen do I have? We have total of 1, 2, 3, 4, 5, 6. Total of 6 hydrogen. So I'll say times 6, which is going to be 6. How many oxygen do I have? Just 1, which is what? 16. So we'll go. This plus this gives me how many? 30. 30 plus 16 gives you how many? 46. Now, what this 46 is telling you that to measure a unit mass of ethanol, I will put my ethanol into this container. I'll pour my ethanol into this container. Now, I'm pouring my ethanol into this container and I will weigh it. And once I weigh it, I realize that the mass is now 46 grams. It means it's a unit mass of ethanol. I repeat, I am pouring my ethanol into this container. And I must make sure the mass that I will get from that container must be equal to what? 46 grams. Once it is 46 grams, it means the mass of container here, the ethanol here, is just a unit mass because it's 1 mole, which is a unit mass of ethanol. In the case of water, I will measure how many? 18 grams because hydrogen is 1 times 2. Oxygen is what? 16. So when you multiply them, it's 2 plus what? 16. And what am I going to have? 18. It means I will pour my water inside here. And when I pour it inside this container and I weigh it, if it gets to 18 grams, it means it is 1 mole of water that is inside here. Because that 1 mole of water is equivalent to what? 18 grams of water. Now, listen to me. Now, I have measured my unit mass of ethanol and my unit mass of water. Now, I want to determine the specific heat capacity. Remember, it's a unit mass of ethanol and a unit mass of water. A unit mass of ethanol weighs 46 grams. We know that already. While a unit mass of water weighs how many? 18 grams. You know that already now. We are supplying the same amount of heat to both of them. We are supplying heat now to them. The same amount of heat you are supplying here is also the same amount of heat you are supplying for water. And then we have our thermometer. When you start supplying heat, you will realize that this heat you are supplying before this one will get to 1 degree Celsius will not be the same amount of heat you supply for this one to get 1 degree Celsius. To raise the temperature by 1 degree Celsius or 1 Kelvin, that is the amount of heat required to raise a unit mass of that substance by 1 Kelvin.